In this video, we're going to learn how to go from a graph to a function for a wave that conforms to a sine or cosine type waveform. Before we begin, we'll take a real quick look at the parent function of the sine and cosine. You notice the sine starts off at 0, the origin, starts by crossing the x-axis, rises, then comes back down to the 0 point halfway through its waveform, and then goes on the negative side until it returns back to the 0 point. The period for the sine function is 2 pi. With the cosine as well, the period is also 2 pi, only instead of starting at the 0, it's starting at its maximum peak, goes down towards the 0, and then through to its minimum value, returns back up by going through the 0, and then finishes its cycle at the top for its maximum value. Now, when we're going from a waveform to either the sine or cosine, we have a number of options. Typically, you're going to be asked to put it in sine form or cosine form. If you're not asked for one or the other of those forms specifically, then it's your choice. And I'll try and cover that as we go through this. The first thing to do is identify your key features of the graph. Notice where the peak values are. Notice where the minimum, and I should say the minimum and the maximum values are. Notice the shifting. This is definitely shifted down. And it looks like it's shifted either to the right or left, depending on whether we decide to go with sine or cosine. So the first thing we're going to do is we're going to go ahead and identify that vertical shift. Now, the vertical shift in this case is identified by looking at our maximum point, the y value for our maximum point, which in this case is 1. And we note that because the max value is right here, and we follow it across, that crosses the y-axis right here. So with our vertical transformations, we're always looking at the y-axis for our values. So vertical shift, we're going to have 1. The minimum value down here, our vertical shift is going to, or I'm sorry, vertical y-axis, y-intercept here is going to be at -5. So we're going to go 1 plus a -5, which is, and we divide that by 2. That'll give us the midpoint. So this is going to be a -4/2, which means our vertical shift is going to be -2, or a downward shift, which makes sense with what we're looking at in the graph. The next vertical transformation is going to be our amplitude. Now, our amplitude is found by taking that maximum, which in this case we found as being 1, the y value for the max, and we're going to subtract from it our vertical shift. So we subtract our -2, and that's going to give us 3, which means our amplitude is going to be 3. Now, before we move on to our horizontal transformations, I'm going to go ahead and draw that vertical shift in here so that we can see where our x-axis really is. This is going to help us later on as we work on the horizontal shifts as well. Okay, so with our vertical shift and our amplitude already taken care of, we can now go ahead and focus our energies on the horizontal. Now, the first thing that we can identify here is going to be the period. And when we're identifying the period, we can choose to go from our max value to a max value, a min value to a min value, or some other point that's easy to identify. I personally choose one of those because it's usually the easiest thing to identify. Now, when we're working on our horizontal shifts, we're going to be working on the x values. So in this case, we've got our max value right here. That's going to bring us across right here, which looks like the 3/2 pi, which would be 7 pi over 2. Okay, so we have a 7 pi over 2 x value right here. We go to our next peak over right here. This is going to be at the pi over 2 value. And so in order to find our period, we take the furthest right point, which in this case is going to be this peak right here. We're going to take that x value, which is going to be pi over 2, and we're going to subtract from it the left value here. So we're minusing a negative 7 pi over 2. And so when we finish this out, our calculations are going to show an 8 pi over 2 or 4 pi. Okay, the final thing that we need to find here is going to be our phase shift. Now our phase shift is going to be determined by whether we want to go with a cosine or a sine. Now in this case, remember a sine crosses at 0, our cosine crosses at a peak. There doesn't seem to be an advantage going one way or the other because this neither starts at a peak nor does it start at the midpoint, this midline here. So I'm going to go ahead and choose my sine. And so we'll do the shift for a sine. Now we can shift either right or left. So I'm gonna show or demonstrate that for both of these in this case. Now for the sine, I think it's more difficult to do simply because we'll be looking at the midpoint going on a positive slope instead of looking at a peak, which is far easier to see. So for the sine, we're looking at, if you notice our midpoint right here, if you notice the sine wave is in the process of climbing, it's going up. So we're going to be looking for that point on this graph in which it's going up. And so we've discovered one on the negative side, the first one on the negative side that's going that way. And this is the first one on the positive side going that way. Now, putting in that vertical shift here earlier helps a lot in identifying where those points actually are. And it'll also help in identifying what that shift actually is, what that phase shift actually is. So in this case right here, if we're going to go to the right side, which is the positive side, we begin by starting with the 0. Now that 0 comes from our origin point right over here. And we're going to subtract from it the point that we're going to on this side here. So if we start at the 0, we're going to go over this way. We've got 2 pi here, 3 pi here. So it looks like we're shifting over 3.5 pi over 2. So that's 7 as an improper fraction. That's 7 pi over 2, which gives us a right shift of negative 7 pi over 2. Now, if we chose to do the left side, again, we start with 0 because that's our origin point. And in this case, we're going to subtract when we move and look at this side here. We're going to subtract a half pi, it looks like, 1 pi over 2. And so to go to the left, we're going to be adding pi over 2. Now, just to make sure that we're clear on how this works, if we're going to the right, we're going to look for this point right here, and our phase shift is going this way to the right. So that's our right phase shift. And again, it's the x value because we're looking at a horizontal shift. Now, if we're looking at the left part, that's going to be this right here, just from the origin over, and this is going to be our left phase shift. Okay, so we've actually found all of our key features at this point, and now what we need to do is modify them so that we get our A, B, C, and D values. Now the nice part here is that for our, I'm going to go ahead and change the color here as we come down the home stretch. Our vertical shift, -2, we don't have to do anything to that. Our D value is equal to -2. Our A value, again, we don't have to do anything to that unless we were planning on using an inverse or reciprocal, I should say, reciprocal form of the sine or cosine wave, which in this case we don't need to. So our A value is going to be 3. Our b value is found using the period, and the formula for doing that is going to be our b value is equal to the the parent function period over our waveform period. Okay, and so in this case, parent function period is 2 pi because we're using sine or cosine. The waveform period we found is going to be 4 pi, which means that our period is going to be 1/2. Okay, so we've now found, I'm sorry, not our period, but our b value. And the final one, our c value, is going to depend on whether we go right or left. We've already found those here. One's there, depending on whether we go right or left. So let's go ahead and look at what this function is going to look like. When you're putting it into the final form, there's a couple of things we need to keep into consideration, and that's the distribution of the b value. So we'll do our right form first. And so our f of x is going to be equal to our function is equal to our a value, which is 3. And we chose to go with sine. On our b value now, which is 1/2. Now we need to put another parentheses here, okay, because this is the distribution of the b value that I was talking about. Our x, and then if we're going to the right, we're subtracting 7 pi over 2. And then our double parentheses and our d value here, which is going to be -2. Now we would go ahead and distribute this half through here, and our final form for this function is going to look like this. 3 sine by 1/2 x minus, we multiply this through, minus 7 pi over 4, and then -2. Okay, and this is, again, if we go to the right. If we choose to go to the left, because we have that option, we found that. We don't need to. We only need to do one of these. But if we went to the left, it would look like this. All of our values would stay the same except for our c values. So it would be 3 sine 1/2 x plus pi over 2 -2. The final form then for this would end up being 3 sine 1/2 x plus pi over 4 -2. And so this would become one option here. If we did the cosine, the only difference here would be that instead of going for our midpoints here, we would go for the first peak on the right, or our first max point on the right and the first max point on the left. And we would choose one of those, and we would be able to come up with the function or the same way.